Hi, welcome to all. Here we will see different aspects of anomaly detection problems. First one is nature of input data. The problem will be defined on the based upon the given data set, either supervised labeled data set or unlabeled data set. Based upon that, we can define the problem and types of anomalies, either point anomaly, contextual anomaly, or structural based anomaly, and aspect of output. Here also we will define the problem and evaluation of different anomalies detection techniques. Here, when we are defining the input data, most common form of data handled by anomaly detection technique is a record. Here the record is having that is differentiated by univariate feature and multivariate features data set. Univariate in the sense the data set will have only single feature, so the single feature data set is called univariate data set. And if our data set is having multivariable multi features x1, x2, x3, x4, x5, so this data set is called multivariate data set. And uh, based upon the nature of attributes, we can define the problem. Here binary data attributes or categorical attribute or continuous attribute. Here this field, this attribute is a categorical attribute because it is having the sequence of data. And this one duration is here, this one is numerical data, that is the continuous values. Here again categorical data, and this one is again numerical data which is continuous values, and this one is binary data. So depends upon the attributes also we can define the anomaly detection problem. And here complex data type is given. The relationship among the data instances may be sequential, that means temporal data type, time series based data, and spatial data, that is locations, x coordinate, y coordinate, and a combination of spatio-temporal, for example GPS mapping system, and graph network based system. So these are all the data will be called complex data types. So previous data are here, these are all normal data type. Here this one is the complex data type. So based upon the complex data type also we can define the anomaly detection problem. And the next one is here, based upon the labels data set, we can define that data set is supervised aspect or unsupervised aspect. Supervised anomaly detection, here the data set will have labels with normal data points and also anomalies data points. Example, we can use different algorithms under the anomaly supervised anomaly detection: autoencoders, Bayesian belief network, SVM, KNN, etc. And in semi-supervised anomaly detection, few data will be available in the with the labels. That few data will be the normal data. Normal data will be available with labels. Abnormal data, that is the anomaly. Abnormal data in the sense anomalies will not have the labels in the semi-supervised learning data set. And in unsupervised anomaly detection method, entire data set will not have the label. So here the similarity pattern will be used to identify the pattern of given data points. Here, based upon the assumption that anomalies are very rare compared to the normal data, here we can use different clustering approaches to classify, I mean to cluster the given labels, given data as a normal data points or anomalies data points. And depends upon the type of the anomaly aspect, we are having three different anomalies: point anomalies, contextual anomalies, and collective anomalies. Point anomalies, here individual data point is called anomalous with respect to the normal data. Here this individual data point is one of the anomaly data point. So here individual every data is called anomaly. So next one is the contextual anomalies. Here individual data instance is anomaly with respect to a given context. It requires notion of context. For example, this is the temperature for a month, for a year. So here, March, it is going gradually. Suddenly, at the month of the December, look at that, gradually it is decreasing. So this is normal. So because this is now gradually increasing and gradually decreasing, so this one is the normal data point. But in this June, suddenly it came down and suddenly it go up. So it's a sudden down is there. So this kind of situation is called anomaly situation, abnormal situation. So that is what here the data point should have notion of context. In that particular context, this down is called anomaly temperature, so abnormal temperature. So here, which is called conditional anomalies. Another name of this anomalies, conditional anomalies. Here, collective anomalies is called related data instances in the given data points. So here it requires relationship among set of data instances. Here the sequential data may be a collective anomaly, spatial data also may be a collective anomaly, or graphical data also may be a data anomaly. Here, the individual instances within a collective anomaly cannot be a anomaly by itself. For example, here the ECG signal is given here, electrocardiogram signal, which is normally which is going on after this point, from this point to this point. So in this gap there is sequential data. This is sequential data, time series data, sequential data. Here the suddenly there is no response. So this process, this position is called anomaly. So here we are having collective data instances. Here instances 1, instances 2, instances 3, etc. The time period, particular interval. So we will have n number of data instances. So this kind of situation is called collective anomaly. And here the next one is with respect to output of anomaly detection. Each test new data point is given a normal label or anomaly label. So based upon the output also we can define the anomaly detection aspect. And sometime we can give the score. Here we are giving the label, either that particular data instance is normal instance or abnormal instance. Abnormal in the sense anomaly data instance. Sometimes we may use score ranking. Okay, so here the each test instance is assigned with the anomaly score. Here we will use ranking value. For this we have to set some threshold value. For example, when you are making the mark statement or grades for for a 100 members, if suddenly only few members, 2 members are getting scored 0, then that 2 members are different from other group of members, 98 members. So these people are anomalies. So here we have to set set the parameter for evaluating that, I mean setting the score. I mean less than 50% or 60% is like that, we need to set the threshold value. And next one is here anomaly detection schemes aspect. Here we are having different detection schemes, graphical and statistical based detection schemes, distance based detection schemes. Here we will use the plots, graphs, pie chart, bar chart, or any scatter plot. We will use box plot for visualizing the outliers, and that means anomalies and normal data. Here we will use the distance based metric, for example Euclidean distance, Manhattan distance or Minkowski distance. Here model based. So different models we will have, that is a small anomaly model and normal data. So based upon that we will differentiate the normal data points and anomaly data points. For that we have to build the profile for normal behavior, the pattern which is related to the normal data point. Then based upon that we can find out the anomalies whose characteristics are differ from the normal data profile. So based upon that, we can define the anomalies. So here the given data point is having given data set is having n number of data points. Here in this one, these data are clustered in single class and or single group, and these data points are far away from this clusters or group. So these kind of data points are called anomalies. So these are some of the aspects for detecting the anomalies in different context by using different methods. Thanks for watching.